Gaines, and this is my Physics 2 Lab 2 Lines of Charge lab. The analysis of two pieces of charge tape is redone to consider the charge of the tape as being uniformly distributed over the tape. Charges of the tapes can be determined by using equivalent and relative interactions of the two charge tapes with uniform charge distribution. The first two key concepts are the second law and gravitational force on the Earth's surface. Newton's second law states that the net force on an object is equal to the changing momentum of the object over the gravitational force on its surface equal to the mass of the object multiplied by the gravitational constant as moving in a negative one direction. The electric force is also an important concept. This non-contact force states that the force on a charged object exerts on another charged object equal to the two equations shown. Importantly for this lab, the electric force is equal to the product of charge and the external electric field of the charge. The materials of this lab include clear tape, flat surface stackable objects, and metal. The system includes tape, the surroundings of the force, and the initial conditions of the neutral surface of the table, and the tape will be placed on the surface as little as possible until very touching. The experimental design of this experiment begins with charging the upper piece of tape. To do this, you use the piece below it, and now the tape is attracted to it. Next, the tapes will be attracted to each other, and the tape will be attracted to the neutral object because of dipole interactions. So to do this, I calculated the force of gravity on tape B by using the formula below, and I also calculated a charge on tape B by using Fc equals kq squared over r squared, and I solved for q. So in VoiceScript, I began by using my constants and putting in my Lab 1 data, and I set Q to be what I found it in Lab 1. I ended up making a change to this so the magnitude of the electric force is equal to the magnitude of the force of gravity. Next, I defined my electric field, and with the line charge function, I created the top and bottom tapes, and this showed nested for loops which demonstrate superposition, which we also did in class. And this is the visual output from VoiceScript. So we have a force upward from the electric force, and then a force downward from the gravitational force. And then we show that there's also an electric field, and we know that these two are both equal to each other. So when we're comparing the actual data versus the model, we know that the computational model always assumes everything is isolated, which isn't always true in the real world. And most of our data was actually pretty similar to the model, but we assume that our data is likely more accurate than the computational model. So some possible sources of error in this lab include human error, so just not calculating things correctly or having issues with the tape, like touching the tape too much so that the charge is dispersed when you didn't actually want it to be. Some of our assumptions for the lab was that air resistance is negligible, that the long tape is a point charge, and that the U-tapes have the same amount of charge, which probably isn't correct. And then we found the magnitude of the charge is 1.96 to the negative third coulombs. So if we had modeled each of our tapes as a single point charge like in the previous lab, we would see that the point charges are equal to 7.4 to the negative 8th coulombs, and that the line charges are equal to 1.5 to the negative 8th coulombs. So why do these estimates differ, and which is more likely to be close to the real value, and why? They differ because one is approximated and the other is not, and we think that approximation is closer to the real value because it takes into more confounding variables and it doesn't just assume that everything is the same like the computational model does. This concludes the end of my Lab 2 for Physics 2 at the Georgia Institute of Technology. Thank you for watching the video, and this was completed by Maddie Gaines.